Okay, so all right, it's recording. So let's carry on. So they have both same come on, what happened? So afterward you have a p2 prime vector is magnitude, and p1 prime vector magnitude, they're the same, and we can just use this one small symbol like that. And because of this whole thing is the same way, you can show it. So I'll just write down, show that the kinetic energy in the final or after is equal to p1 prime square over same 2 mu. So it has same formula as you had kinetic energy before, except now you have p1 square here, you have p1 prime square here. So momentum magnitude can change, but their directions to be opposite, so they kill each other. Okay, so we have a kinetic energy after, a kinetic energy before is p1 prime square over 2 mu, and p1 square over 2 mu. These guys cancel, and you have a p1 prime square over p1 square. Okay, so I just worked out this far is very good. So how can we relate this? How can we relate to epsilon, which is in our case, if this is x and this is y, and they were coming in this way, so the normal v2 prime, so this is the normal direction, and this is the tangential direction for us. So it's just x direction, v2 prime x minus v1 prime x, that's the relative for that, and v2x minus v1x. How can we relate these guys to those guys? So let's see. Okay, so let's see what epsilon will be. Let's write down epsilon, and we'll see pretty cool, pretty interestingly. Epsilon will be v2x prime minus v1x prime over v2x minus v1x. When we work this out, let's write the momentum, so we can, if we get to that distance, we can just use this ratio to replace that. We can just call this alpha. Okay, that ratio alpha. So this will simply be the momentum p2x prime over 2m2, right? And then it's going to be p1x prime over 2m1, and so this will be p2x over 2m2 minus p1x over 2m1. When I'm doing this on the small screen like this, usually it's a pretty hard to do it. Let's see what. So p1 prime is that way, and p2 prime is that way, and this is the theta, and this is the x. So, and magnitude of p prime, I mean, p1 prime is equal to p2 prime equals to p, just writing it like that instead of all that extra symbols. So this one is this much, and this one is this much. So p2 prime x is, so this is theta, and this distance is p1 prime is equal to that, and so this one is minus cosine theta. So this is first just get rid of all the 2's down there, because and then let's write down like m1 p2x prime minus m2 p1 x prime, m1 p2x prime minus m2 p1 x, and this is not prime. All right, so, and then what do we have? We have using this, you have m1 minus p1 prime cosine theta, and this one will be plus cosine theta, minus m2 p1 prime cosine theta. So these guys will add, and down below will be m1. So these are before p1 was coming in and p2 was coming in, which is equal to p1. So, and this is the x direction. So this is positive, this is negative, minus p1 minus m2 p1. So p1 prime is common to that, p1 prime cosine theta is common, so minus m1 plus m2 p1 prime cosine theta over minus m1 plus m2 p1. They cancel this guy, this doesn't cancel, they're different things, this go away. It's actually a really nice problem. So you have a p1 prime over p1 cosine theta. So if I go that alpha, just is the kinetic after over kinetic before, that was equal to p1 prime over p2 or p1 square, and we have p1 prime. So this is cosine theta will be positive, okay, for the forward scattering, negative for the backward scattering. So this guy is, this positive and this positive, the magnitude. So this is going to be square root of alpha. That's right. This is going to be square root of alpha cosine theta. So epsilon is square root of kinetic energy after or kinetic energy before cosine theta. This will be square root also, yeah, it's inside, yeah. No, this is not a square. This is outside. This is outside. So, okay. So epsilon square is actually related to k after but k before cosine square theta. So if you had a, say it was just one dimension, it went in, this is before, and then after then if you look at the one was this direction before, and then one, so this theta will be 180 degrees, and that make it epsilon square will make it k after k before times 1. So only in this case, but in all the other cases the relationship actually depends on what was the scattering angle also. But this is a nice relationship. I hope I didn't mess it up somewhere in the calculation. But you know, you can see that epsilon itself is a nice proxy for what fraction of the kinetic energy was actually lost. It's a proxy. It's not exactly the same thing. Okay, that's what this calculation shows. All right, I'm going to stop it here, and I hope you learned something. If I made some mistake, you can show it to me later. I don't know where. I mean, this is today's, and the other one's from yesterday. Okay, so I will talk to you in another video. Take care. Bye.